Okay, guys, continuing on with 1.7, I want to look at this question number C to continue from that A and B that we did. So once again, we have this linear inequality. Okay, so I'll go ahead and I see that I have an X here and I have an X here. And usually when we have a rational equation, think about what we usually do is we try to eliminate the fractions. So that's exactly what I'll do is I'll realize, okay, well, in this inequality, I have an LCD of -8. So I'm going to go ahead and I'm going to multiply both sides by that LCD, right? Remember, that's how we would solve it if it was a rational equation. And notice what's going to happen is these are going to cancel, and then I'll have to distribute this. So I'll get 2x minus 5. Now be careful. What did we do to both sides? We multiplied both sides by -8. That means that we have to remember that this sign is going to flip, just like so. Okay, so really take note of that. If I distribute, this is -8 plus 8x. And now I'm going to solve it just like, like we talked about before, where we treat it as an equation with any flips if we need to. So I think it makes sense to subtract 2x from both sides. So that -5 is greater than or equal to -8 plus 6x. Get rid of that pesky -8. So 3 is greater than or equal to 6x. And as you can see, then x has to be less than or equal to 1/2. Or, if you like it better, I like to write this as x is less than or equal to 1/2. So let's first do the graph, then we'll write our answer in interval notation. The graph for this, once again, this is less than or equal to. So here's 0. Suppose this is 1/2. Less than or equal to 1/2. So I want to include 1/2, and it's everything to the left. Now, if it was greater than or equal to, then I would have shaded everything to the right. I guess my examples are just happening to always be less than or equal to. In our answer in interval notation is the following. Okay, we're going to go from something super negative, like -infinity, and go up to 1/2 and include it. And there's our solution. One other thing I want to do here in this video is an application of these inequalities. So what we call this is break-even analysis. It's done a lot in businesses to figure out if taking a certain action, if it's going to be profitable or not. So suppose we have this situation. The revenue and cost of a certain product, so you're running a company, and remember, revenue is what we're going to make. So say the revenue is 60x. What that means is if x is the number of units, right, then if you sell 100 units, your revenue is going to be 60 times 100. X is, say, your units. And we also have a cost. Maybe for each of those that we're making $60 on, it costs $50 to make it with the materials, the labor, that kind of thing. 50x we call the variable cost. And it varies depending on what x is, how many units you use. So you can think of that as cost per unit. Okay? And the 5,000 right here is known as your fixed cost. So that could be maybe the rent on the building that you're renting or whatever. Okay? So we have a revenue function and we have a cost function. And the question is, for what range of units will you make a profit? Okay? Now, there is a very simple equation that profit, so how much money you take home at the end of this whole operation, is equal to revenue minus cost. What you make minus what you spent to make all those. And really, I should say not what you made, what you sold minus what you spent to sell, to make those things you sold. That'll be your profit. And that's what we want to know about, is profit generally, right? So really what we want to know is we want to know, when is revenue greater than cost? Because if revenue is greater than cost, we'll have a positive profit. If it isn't, we'll have a negative profit, and that's definitely not a good idea. So we have revenue as a function of x, this 60x up here, and we want to know when it's greater than the cost, so C of x. Okay, so 60x is greater than 50x plus 5,000, and we're going to try to solve for x such that revenue is greater than cost. So we're going to do this just like we've been. Subtract the 50x. We're getting these on the same side. Since this is a linear inequality, 10x is greater than 5,000. Divide both sides by 10. Don't have to flip any signs. Nothing's negative. X is greater than 500. So if you can't sell over 500 of whatever you're making in this hypothetical company, I wouldn't do it, right? Unless you're very confident. And you probably want to sell considerably more than that so you can pay yourself, a fair amount. I'm assuming that the cost is figuring in, the variable cost is figuring in salaries for your workers, everything like that. So if you wanted to break even, 500 would be the magic number when revenue is equal to cost. So this tells us that you must sell more than 500 units to make a profit. So if that's not going to happen, don't do it, right? You'll break even at 500. That's called the break-even point. Okay, so 500, that's your break-even point. And you don't really want to do that either, because then you've done all this work and you have nothing to show for it, right? All right.